All right, we're getting right back into the 1-5 notes. You're going to be finishing off these notes, filling in the examples by listening to this video. If you need to pause or go back through, you can certainly do so. I will go fairly quickly to get this in a manageable amount of time. So we identified the terms up above: adjacent angles, vertical angles, complementary angles, and supplementary angles. We're going to now identify some of those angle pairs in this picture here. Name one of each type. There could be more, but we're just going to name one to give an example. An adjacent pair of angles, angles that are coplanar, they have a common side and a common vertex. One of those would be angle BFC and angle CFD. All right, so that's BFC and CFD right here. A pair of vertical angles. There is at least one pair of vertical angles. So to name one of them, I'm going to name angle AFE, angle AFE, and angle CFD. You should expect with vertical angles to have the same vertex, just like adjacent, so that in the middle, and AFE right here, and CFD, right? These angles right in here. And we know that special thing by watching that video from Pearson is that vertical angles are congruent. A pair of complementary angles, for example, could be angles that sum to 90, BFC and angle CFD. And an example of supplementary angles. Supplementary could be more than two angles. Could be supplementary. We could have three. I will give you a pair of them though. Angle AFE, angle AFE, right here, the 62-degree angle, and angle EFD. Supplementaries have to add up to 180, so commonly we will see these angles fall along a straight angle. So angle AFD is a straight angle measuring 180 degrees, and then these two angles here add up to 180, which are the examples that I gave. Here's another type of problem you could be asked using the information angle pairs. What can you conclude from the diagram? So some of this might bring back some things that we already know from Chapter 1 in geometry, and it's a very open-ended question, but you have to make sure whatever you conclude does have backing from information that you pull from the picture. So for example, here we have these slashes across two of our line segments. These are markings of congruent line segments, so we can conclude that segment TW is congruent to segment WV. So there is our conclusion for letter A. Letter B, there are more things that we can conclude. We're looking for angle pairs based on definitions we learned up above. I'm going to start off with these markings of congruent angles. Angles 1 and angle 2 are marked as congruent, so I can state and conclude that angle 1 is congruent to angle 2. Also, I could conclude, knowing that angle 3 and angle 5 form a pair of vertical angles, that angle 3 and angle 5 are vertical angles. Angle 3 and angle 5 are vertical angles. Right? And then finally, I'm going to conclude one other thing. There are some other things we could conclude, but we're also going to say that we recognize here, for instance, that angle 4 and angle 5 are supplementary angles. Angle 4 and angle 5 are supplementary angles. There are other things to conclude, but we'll stop there with that. Let's turn to the back, and we need to define a new term on the back. This new term is linear pair. A linear pair is a pair of adjacent angles. They have to be next to one another. Pair of adjacent angles whose non-common sides are opposite rays. We know from a previous lesson that opposite rays simply form a line. So these adjacent angles lie next to one another along a line. All right, so let me give an example here. All right, so I drew two different rays coming off of this line here. And I'm going to put some points along here so that we have some things to name. All right, so if you need to, you can pause and you could copy this picture over. BE, ray BE, and ray BC are opposite rays. They form a line. And an example of a linear pair in this picture is angle EBA and angle ABC are a linear pair. All right, and if you follow EBA, and then if we follow ABC, we see that they form a linear pair. So really, ray BD is irrelevant to our linear pair. Let's fill in the postulate, which is a statement of fact. It will always be true that if two angles form a linear pair, then they are supplementary. They add up to 180. And we're going to use this postulate to show the example down below, problem type number 3, find the missing angle measures. We're just going to do letter A. There's actually two problems here, so you may want to take a minute to go ahead and separate them. It wasn't real clear on the original notes handout. I'm going to zoom in a little bit more on letter A. I did draw a picture to go along with it, so you could surely do the same if it's helpful. But we are told that angle ADB and angle BDC are a linear pair, which means they're supplementary. So we know that measure of angle ADB plus the measure of angle BDC are equal to 180. Because they form a linear pair, they are supplementary. You can see my picture over here. I'm going to go ahead and I'm going to substitute in the expressions for my angle measures that were given to me in the problem. And I'm going to use algebra to solve for x, and then I can find my angle measures after that. So I'm going to combine like terms on the same side of the equation. I'm going to use inverse operations, properties of equality, subtraction property of equality, subtracting 12 from both sides, and division property of equality, dividing both sides by 8 to get my value of x is 21. And once I know that x is 21, I can find the measures of my angle. Measure of angle ADB, I'm going to substitute in 3 times 21 plus 14. So ignore my first marking there. ADB should measure 77 degrees. And then the measure of angle BDC ends up being 5 times 21 minus 2, and that should come out to be 103, which is a good thing because these two are supplementary, so they should add up to 180. You could take the time if you wanted to give letter B a try. If you are trying out B, I will write here that x equals 20, and then you could substitute back in show them what you would do. What would you do to get x equals 20 if you give it a try? All right, one other term and one other example before you finish off the 1-5 notes. Angle bisector. We have already come across bisector when we had segment bisector. Bisector of an angle of a segment is going to split something into two congruent parts. In this case, an angle bisector is a ray that divides an angle into two congruent angles. So we have a picture over here to the right of angle XAZ. An angle XAZ is split into two congruent angles by ray AY. We can see the congruent markings. So I'm going to say down below here that ray AY is an angle bisector of angle XAZ. Right? We can then apply that definition of angle bisector to answering a question like the one we have at the bottom. It's not absolutely necessary, but you could sketch yourself a picture of some sort. We have that ray KM bisects angle JKL, so I just drew angle JKL. I don't know exactly what the measure is, but that's okay. It will just help us think about it. And then I want to put in ray KM. K's already there. I'm going to put point M. And it says it bisects, so I'm going to go ahead and put my markings of congruency because KM is an angle bisector. If the measure of JKL is 72, what is the measure of angle JKM? Well, what we know is that these angles, in finding one of them, we're really able to find both. So I'm going to put an X in both of these because if we add X plus X, we would get 72, the measure of the whole angle here. So we can find X by solving this, and X should be 36 degrees, which means the measure of angle JKM is 36 degrees. Right? We will have ones that have more algebraic expressions than just X to them, but this gives you an example. That's it for the 1-5. If you need to go back and re-listen.